Hello, how are you? I'm going to talk about some of the applications layer protocols. When you get the book, you'll find that these are in the chapter 2, but everything I'm going to be doing today I got from the web, so you don't need the book to go through this. You can get them even more detail from different places on the web. In the last setup, the last video, we talked about the transport control protocol. This is the main protocol that we use to send things across the web. Again, I remind you that what happens is that an application creates whatever it wants to send, and it passes it to the TCP, to the transport layer. And the transport layer is responsible for getting it to its destination. Now, this is the one that most of the things we do use. It's a good one. But there's also one called UDP. And I'm not sure exactly what the letters stand for, but basically this is the one that is a quick and dirty one. So this is a simple, quick alternative to the TCP. And we're going to come across this very shortly with one of the things we're going to do. I reminded you in that last video about IP addresses. The internet uses IP addresses, but we use domain. We use URLs, the Universal Resource Locator. We use euros instead. How do we connect the two? That's what this is all about. How do we get from knowing what a euro is to the IP that the system needs? Now I've got some of that written down here, so I'll just bring up what I have below here. The answer is the domain name server. Domain name server. A domain, an example domain is providence.edu. Every ISP provides a server which the users of that network use to request the IP for a given URL. Once we get it, we may save it for a while so that we don't have to keep asking. But we don't keep them forever, and we don't keep there are millions out there, and there's no way I'm going to be able to store all of them. So the ISP is meant to, the ISP gives me a way to do it. Now I don't even need to know what the domain name is. This is done automatically behind the scenes. However, we can look at it, and that's what I'm going to do right now. I'm going to bring up a Wireshark. And I'm going to bring up one of the things I have out there so we can look at it. And I've broken it up. I clicked on protocol so that I would have it organized by the protocols. Now right here in this little line here that's between the icons and the beginning of all the names, I'm going to type DNS. Doesn't want to do it. There it is. These are the calls that were made back and forth between me and the DNS of our ISP. In this case, this would be the Cox ISP because that's the network I'm on. I'm 2600, 8805, whatever. And I'm going to a particular place. Now, this first item here, I'm going to open it. I'm going to go down here. The first thing to notice is that we don't have a TCP. So the first step I want to say is DNS uses UDP. It doesn't feel it needs the other. However, DNS can use TCP. I was looking on the web, and there is some information there on how it uses TCP instead of UDP. But it's one of the applications that's known for using UDP. So let's go back to where I am. That's this one here. I now know what it means, user datagram protocol. And if you look in here, there's a destination port of 53. In fact, if you look at any one of the queries I sent, you'll find the same 53. That's because many of the applications have a well-known port number. So let me get that right here. DNS is a server that most sites assign to port 53. This is a well-known port. There's a whole list of these that when you set up your site, these are the places you're supposed to put things. In your homework, you might notice that there's one of these for TCP also. Now let's look again at this setup. The UDP is not very much, as I said. It doesn't have all the things that the TCP had. And the payload it is carrying is from the domain name server. The domain name server is actually kind of easy to look at. It's in English, well, practically. There's one question in it, and here's the query that I'm asking. So you can see it right there in pretty normal English. I want to know where ctld1.windowsupdate.com is. That's all I'm asking. You can even see it up here. An easier one might be Bing. It's not quite as long, so maybe it'll look better if we did Bing, www.bing.com. This particular frame is asking, what is the IP for Bing.com? And the Wireshark's good. It shows us where it is. Now let's look at that answer. That's in frame 137. So again, I've got an answer. The answers, I have to click here to get them. Well, I'm getting several answers. I'm getting an address. I'm getting some other things called CNAME and all kinds of other setups here. But you'll notice that address is IPv4. And notice it says it's type A. Now let's look at the second, look at frame 136. 136 is also asking for Bing, but it asks for type AAA, not type A. So what's the difference? Let's look at the response. Response, look at the name, look at the address for the response. That doesn't look like an IPv4 address. It looks more like an IPv6 address. So maybe that has something to do with the difference between A and 4A, which is one of the questions I'm going to ask you on the homework. So these are ubiquitous. When you run your Wireshark, you're going to get a lot of DNSs. I mean, I only think I asked for 1 or 2 places, and I got just place after place in the DNS. So that's what a DNS looks at like from the Wireshark viewpoint. But now the question is, what does it do? So we have to be careful. No site on the web has all the addresses, all the IP addresses. What we have is called a decentralized system. Decentralized directory. You couldn't have it any other way. You had a few million, might be getting close to 1 billion websites with IP addresses. You don't want them all in one place. And even if you did have them all in one place and have them duplicated in a few places, the amount of space would be horrible. So instead, many years ago, a system was set up. There are, I believe it's 13 root directories. These are the top of the hierarchy. What happens is you normally go to one of those to ask a question. Now, there's a list of some of them. A lot of them are in the United States. And I looked up some things about them, so I'll see if I can get to them and get to those things. Pardon me, I have to move this up a little because I can't read it. Okay. As you can see, I had a lot of places, so I'm going to have to see if I can find the one I want. No. Yeah, that one can do it. No, it's not the one either. Try this one. This shows you what we're going to be talking about in a minute, the hierarchy. And I want to go to the root, and I want to see if I can get one of them. These are assigned by a group called Internic, and I should be able to get a hold of one of them. I'm not having much luck. Let me see. That isn't what I want. Let me see if I can find it. That's the top level. That's not what I want. Nope. No. 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 I may have actually somehow gotten rid of it. Well, what I'll do is I'll create it for you. So I'll just go here and I'll say, I'll pick one. I'll pick the A root directory. They really got fancy with naming them. They named them A, B, C, D, E, so on. Really fancy way of naming things. And here I'm going to get one of these, as I said. I think Wikipedia will have it. Nah, they don't have what I want. Let's see. Here's what I'm going to do. A root directories sites. So these belong to private industry. VeriSign has them, for example. Root A directory sites. Well, you'll probably have better luck doing it than I will. I think I'm going to call it off right now. But you'll find out that each of these sites, each of these setups actually has many different places where they store their directory. Here it is. This one right here. I knew I had it. Pardon me. This shows you across the whole country how many sites there are and where they are. For example, let's take this directory right here. It's showing a whole list of directories, places where it's storing that information. If we take this one up here, we have more. It shows you that there's a lot. Here they are. This is what I wanted. A has sites in Atlanta, Chicago, New York, Paris, San Jose, Seattle. And if you were to click on, I think I did this, if you click on New York, it doesn't work. Oh, statistics. I always like to look at the statistics of these sites. You can see how many queries they're getting. Big number. And you can see the IPv6 ones, the IPv4 ones, all the different ones they're getting in. So it's kind of fun to see all these sites. Again, the directories are very poorly named. There's A, B, C, D, E, so on, all the way down the line. Now the root directories don't know the answer. What goes on is the root directories direct a requester to the top level directories for the site they want. What are the top level directories? Example, TLDs, .edu, .de for Deutschland, .ch for China, .org. There were originally 8 of the form of edu, org, biz, gov, mil, but they have exploded. There are so many of them. And every country has its own. So they keep track of the sites that end with those particular things. Now, the TLDs may direct you to subsites. I guess they would be called secondary level sites. For example, the .edu could direct you to providence.edu, but providence.edu may be necessary to find some of the sites that we support. They may not all be listed at the top level. Excuse me. That is more or less written out down here. I have a few items here. This is the group that actually does it. IANA, the Internet Assigned Names Authority. And they show you the database of top-level domains, and you can see the number is just huge. Generics, countries, all over the place. There are just so many of them. That makes it easier for any one of them to be a reasonable size. Now, I thought we might look at our own. We're under the .edu for PC, and this tells you all the facts you want to know. If PC wants to buy a particular euro, it would apply to this group. Now, I've been told that we have UP, in case we ever change to the University of Providence. We may even have PU, but I don't know for sure. But we have protected ourselves by buying the sites that would be most likely directed to us. That's fortunate because there are people who buy sites that they think someone else might want and then practically extort money from them for that site. It's not fun, but they do it. There are technical details about it. Things about how to get there, what information you can find. There's a lot of information out here, as I said. It's just so much. But that will give you some idea of what's out there. Now, this is one of the things I got from the web, which might help you see how the DNS works. Unfortunately, in Wireshark, we don't see most of this. This is sort of under the covers. We don't really see what's going on. All we see is the first request. So that is what DNS is about. Now I'm going to go over now to the homework that I made up. The first thing I did was I did my own capture, and I'm showing you parts of that capture. I'm showing you the TC, some of the TC parts of it. And then I'm asking you to find out some things. Now, you may need to go on the web. You may have to look up something. You may have to look up what 45.60.45.167 is. And I gave you a huge hint. Who is a utility that does that. You might want to look that up on the web. But the first homework is just basically to analyze those. The second homework is talking about DNS. And again, I gave you some of my own from what I had, and I'm asking you questions for it. And one of the reasons I wanted to look at this right now is to talk about RFCs. An RFC is a request for comment. When a committee wants to decide, works out what protocol it wants, it asks the world to comment on it. So it sends out a request for comment, which looks huge. And what it is a detailed, step-by ever-loving step of everything you could ever want to know about that protocol. So many of the questions you have about what is this or what is that about a particular protocol, you may go and look up the RFC on it, and that'll give you an idea. As you can see, it just goes on and on. You can notice how bad graphics they had back when they did this. That would never be acceptable today. And there's all kinds of different pieces of information on it. These run many, many pages. But I just gave you some that you might find some of the things you want in. So again, I'm asking you to look at it, figure out some things. Now, I'm also going to put out, I don't think I've done it yet, my second capture yesterday. I believe, was that one or that one? It's this one, I think. I'll tell you in a minute if I can see up at the top there. Well, I think it's capture 2. And what I'm asking you about here is TLS. TLS is something that is aimed at the security of the system. It developed out of what was the secure socket protocol, which we've actually used at PC and we have on our system. And what it does is it does a lot of the TCP work for you. So I have here a stream. The way I got that was that I clicked on one of these and then I typed up here, analyze follow TCP stream. And what it does is show me everything that's connected. Now you'll notice in here things like client hello, server hello, change cipher specification. When you do it, you'll find a lot of unusual things in here. Again, if you want to know and if you're going to get the answers to this, you may have to go and look at some of the things on the internet. This talks about extensions. I'm asking you about extensions. So you may have to go out and look at them. You may have to find the TLS RFCs. I don't know if I don't think I put them there. I'll let you go look for them. But there's lots of pieces of it that are very amazing, really. I think the most amazing thing is that all of this goes on when you just request a page in the browser. you don't have to do all this stuff in the back. Now, there's a protocol that I used to be able to talk about a lot. It's called HTTP. You've seen it over and over, or HTTPS. It used to be you could follow it, but things have changed. Now, the minute we get the HTTP, it goes into TLS. I'll show you over here. Oh, wait a minute, I wanted this. If I were to look here, for example, destination port 443, I think you'll discover perhaps that that's HTTP. They've gotten more security conscious, so now everything's encrypted. Before, you could read what's coming across in here, but you can't do that now. So that's what I want to give you. This homework is basically one with lots of details. I want you to see what it would be like if you had to maintain this at a system, how Wireshark would tell you what is going on. So work on it, and again, you can find anything you need for it on the web. I did lots of Googling. You may have to do the same, and that will give you a pretty good idea of what's happening, I hope. So that's it for now. We'll see you later.